for today. I can solve real-world problems using systems of linear equations. Let's read together. 1, 2, 3. I can solve real-world problems using systems of linear equations. You read it again. 1, 2, 3.
I can solve real-world problems
Okay, so we already know what systems of linear equations are. That's why we don't need the Freyer model. Okay, we covered that last week. And we solved linear systems of linear equations 3 different ways. Remember, by graphing, but by substitution, and the last one was elimination. And we knew that systems were a set of 2 or more linear equations with the same variables. I gave you guys examples, non-examples. And we said the most important thing is that there are 2 or more, and they have the same variable. However, for today, since we're going to be using all these methods that we learned so far, but now we're going to apply them to word problems. We need a process. Copy this down, please. And you're going to label it problem-solving strategy. Instead of writing steps, I want you to write problem-solving strategy. Copy that down. It says, number 1, read the problem at least twice and underline key information. Read the problem at least twice and underline key information. Read the problem at least twice and underline key information. Step 2, use a table to organize information and choose variables to label. Use a table to organize information and choose variables to label. Use a table to organize information and choose variables to label. Step 3, reread the problem and write expressions or equations to represent the relations. Reread the problem and write expressions or equations to represent the relations. Number 4, solve the equations and find the unknown. Solve the equation and find the unknown. Solve the equations and find the unknown. And the last, like always, check. We're going to check to see if our solution is what we found. Copy that, please. So, fairly simple process, and we all do this when we actually solve word problems. However, now we have it lined out, so like that if we need to go back to our notes, we can check off each point, so like that we go through each of these points when we're solving those word problems. Specifically right now when we've got to systems, because the information is going to seem a little bit overwhelming, okay? So copy this example down. Example number 1. It says, example 1, Sonia has $7.75 to buy 12 sheets of felt and cardstock for her scrapbook. The felt costs 50 cents per sheet, and the cardstock costs 75 cents per sheet. How many sheets of each can Sonia buy? Bless you. Let me read it again. Sonia has $7.75 to buy 12 sheets of felt and cardstock for her scrapbook. The felt costs 50 cents per sheet, and the cardstock costs 75 cents per sheet. How many sheets of each can Sonia buy? Copy that, and then we'll go over the process. All right, so once again, according to our steps, our problem-solving strategy, step 1 is to read the problem at least twice and underline key information. I already read it twice. However, I'm going to read it one more time so you can see what kind of information do we have here. Sonia has $7.75. Okay, what is that talking about? Money. So I'm going to box anything related to money. $7.75, 50 cents over here, and 75 cents over here. Okay? So for those of you that have your colored pens, right now it's a good time to use them because we're going to be trying to use 2 different or 3 different colors to differentiate the type of information. So Sonia has $7.75 to buy what? What is she going to buy? 12 sheets, and I'm going to do that in blue. 12 sheets of what? Felt and cardstock. 2 different types of sheets, felt and cardstock for her scrapbook. And then at the end, what it says, the felt costs 50 cents per sheet, and the cardstock costs 75 cents per sheet. And the question, how many sheets of each can Sonia buy? So we're going to figure out how many sheets of each. Okay? So, to get started, did we cover step 1? Did we read at least twice and underline key information? Yes. Step 2, what does step 2 say? Okay, go. Use a table, right? So here goes the table. Everybody use this one. We're going to draw 3 lines down. 1, 2, 3, and 2 across. 1, 2. And like I said, I have already introduced this one in the past, but here it is again. This, from now on, we're going to use to organize our information. Bless you. So, here he goes. Pens down, eyes up here. So, I'm going to organize my information here to make sure I get started well. So, here it goes. It says Sonia has $775. That's her total amount of money she has, right? So, all these amounts could be known as money, or I'm going to label it cost, and you're just paying attention. I'll let you copy in a little bit. So, it's cost. The total cost that she can spend is $775, and that's my total. It goes over here at the end. Okay? But what are we talking about here? What is she going to purchase in order to get a total? She has what? 50 cents here. And what is the other? 0.75. However, by looking at these, how do we know which one belongs to which? I know, because it says here, but I'm saying if somebody walked in and they didn't see this problem, how would we know which one belongs to which? We can't unless we label them. That's why the next step says we need to label it with what? Variables, right? So 50 cents belongs to what? Felt. So what variable can we use for felt? F. So 0.50 F. So 75 cents belongs to what? Cardstock. And what can we label that? C. Copy that, please. Okay, so now that we have our cost, so let me go back to my problem. I'm going to check mark whatever I already used. I already used this, this, and this. Okay, I got that down. So to keep me organized, I know that this column is going to be for my totals. This column, what does it belong to? Felt. And what does this one belong to? Card stock. Does everybody see? Okay. You guys see what I just did there? No? Okay. All right. So we have the cost. Now look what we underlined and circled in blue. They're talking about sheets. But what if I gave you another problem that talked about something else? What would be a generalized word that we use here? Items. Items. They're going to be talking about cost, and they're going to talk about items. So let's see. How many total items does Sonia need? 12. So the total amount of sheets are 12. Okay. But do we know how many of felt?
No.
No. So if we don't know, what can we label it? Very good. F. Okay. How about cardstock? Do we know how many cardstock?
No.
No. Therefore, what can we label it? C. Does everybody see? Okay. So, everybody got it?
Yeah.
All right. So let's see. Step 1, read your problem twice and underline key information. Yes. Step 2, read step 2, please, Gus. Did we do that?
Yeah.
Step 3, Lucy.
Read the problem and write expressions like the savings to a calculation.
Okay, so according to, if we were to read the problem again, the red stuff belongs to the cost, so let's write an equation for this. They're saying that the felt plus the cost of the cardstock will give her a total of $775. Do you guys see the equation if we write this out? This would be 0.50F plus 0.75C equals 7.75. And where did I get this from? From here. So therefore, think about it. What goes underneath here? Think about it. Don't say it out loud. If this I got from here, then what goes here? Who saw the second equation already? The number of felt cards plus the number of cardstock sheets will equal to how many? 12. So therefore this is F plus C equals 12. Does everybody see that? Okay. So step 3, write equations. Step 4, solve for the unknown. We're going to solve the equations for the unknown. And you're saying, but how do we solve that, Mr. Q? Well, let's see them. Aren't those two a system of linear equations? Yeah, we have two equations here. It's a system. How do we solve it? By looking at it, let me see. I would say I have both variables on the same side. They're already in standard form, so I can solve by elimination. Therefore, check this out. I need to multiply one of the two equations times a number to cancel one of the variables. In this case, I'm going to cancel F. To cancel F, everybody look up, please. This one is 0.50. What does this need to be? Negative 0.50. Therefore, I need to multiply the entire equation times negative 0.50. Distribute. This times this, it's negative 0.50F. This times this, that's negative 0.50C equals. This times this, that's negative 6. Where did I get negative 6? Let's see. 12 times 0.50, 0, 10, got 1, that's 5, 6, 2 decimal places, and that's how I get that. Okay? Yes, that's why it's negative. All right. Now we can eliminate. Here it goes. I'm going to draw my line across here. We don't use this middle one anymore because we already multiplied times point and we made it into this. Does everybody see that? So we said we're going to eliminate the S. What is 0.50 minus 0.50? 0. They cancel. So what is 0.75 minus 0.50? That is 0.25C equals. What is 775 minus 6? 1.75. Can we solve for the remaining variable? Yes, we can divide by 0.25, divide by 0.25. C equals 7 sheets. I know, very simple. The only one piece that we're going to have to practice is the setup. Okay? So now check this out. So here, are they giving us a cost for the sheets? No, they're giving us the amount of sheets for cardstock. So what are we missing? How many what? Felt. Now think about it. Which of these two equations will let me know the number of felt? Which of these two equations can we use to find out how many felt? The bottom one, the items. So then I do F plus C equals 12. Some of you are saying, can I just subtract from 12 and just get 5? Yes, but how are you going to show the work? By doing this. So we go. So instead of C, it's 7. Bring down the F plus the equals 12 minus 7 minus 7. F equals 5 sheets. No. Okay. So, did we find the number of sheets for the cardstock? Yes. For the felt? Yes. So now check this out. If we were to write it as a coordinate, from now on, the first variable, everybody look up, the first variable will represent the X, and the second variable will represent the Y. So my solution would be what? 5, 7. Everybody see that? And what is our last step? check. We're going to check. So I'm going to get my first equation, or this equation, the one in blue, F plus C equals 12. And the other one that I'm going to check is 0.50S plus 0.75C equals 7.7. Yes, because we want to make sure that the number of items equal the amount of money she's going to spend. So let's see. So F is 5, C is 7, and 12 equals 12. That works. Very good. Okay. And then over here is 0.50 times 5 plus 0.75 times 7 equals 7.75. So let's see, 50 cents times 5, that's 250, plus 75 cents times 7, that's 7%, 49, 50, 5.25 equals 75. So 250 and 525, that's 7.75 equals 7.75. I was missing one here. So that is true. So we write a statement. Here it goes. So let's write our statement to answer the question. Here it goes. Everybody look up. Let me move this. Let's see. What was the question? How many sheets of each can Sonia buy? So how many sheets of each? So Sonia will buy 5 sheets of felt and 7 of cardstock. Thank you. Everybody got it? Okay, copy this next one down. Example number 2. We're going to do the next one together to make sure we got this process. It's the same thing, but I'm going to change the items and the amount of money. Here it goes. Copy this next one. Example 2. It says, Chaim spent $14.85 to buy 13 flowers. Aww. He bought lilies, which cost $1.25 each, and tulips, which cost $0.90 each. How many of each flower did Chaim buy? Copy that, please. Go. So, step 1, read the problem twice. Read the first time, Gustavo. Gustavo.
Again, spent $14.85 to buy lilies, which cost $1.25 each, and tulips, which cost 90 cents each. How many flowers did Chaim buy?
Okay, here goes the second time. Chaim spent $14.85 to buy 13 flowers. He bought lilies, which cost $1.25 each, and tulips, which cost 90 cents each. How many of each flower did Chaim buy? So, let's underline information. First things first. They're talking about money, so let's box anything that deals with money. That one, this one, and this one. Okay? Next, I'm going to box or underline anything involved with the items. He's buying 13 flowers. And what kind of items? Lilies and tulips. Okay? All right, and let's underline the question to make sure we address the question at the end. How many of each flower? How many of each flower did Chaim buy? Okay? So did we read it at least twice and underline key information? Yes. Step 2, write a table to organize our information and select variables. So here we go. 3 lines down, 1, 2, 3, and 2 across. Okay? We know that at the end here is the total. So right now I'm going to write total. And I'm going to start with my first row right here, which is what? What was the key word? Cost. Cost. All right. So what is the total cost of the total amount of money Chaim is going to spend? $14.85. Okay. So what was the cost for the first flower? $125. And what kind of flower was that? Lily. There it is. What is the type of second cost? Was what? 0.90, which was a tulip. Okay. All right. So we know that this one is for lilies, and this one is for tulips. Okay. Bless you. So now we're gonna write our information for our second part, which is the items. Items. All right. So let's see. Do we know how many lilies he's gonna buy? No. So we label it L. How many tulips? No. So we label it T. And how many total flowers is he purchasing at the end? 13. Okay. Therefore, step 3, write expressions or equations according to our information. So let's see. Does everybody see the equation here? 1.25L plus 0.90T equals 1485. Our second equation is L plus T equals 13. So now in this case, we have them in standard form. The easiest method will be what? Elimination. So which variable, think about it, would you like to eliminate? You want to eliminate the L or the T? T? Okay, let's eliminate T, since people want T. So let's see. So to eliminate T, if this one's 0.90, what does this need to be?
Negative 90.
Negative 0.90. So we're going to multiply this entire equation times negative 0.90. So this becomes negative 0.90 L. Distribute to here. We got negative 0.90 T. Distribute to here. We get negative, let's see, 13 times 0.90. 0, 7, we got 2, 9, 10, 11. 11, negative 11, 70. All right? So far, so good? All right? So, let's eliminate that variable. Let's look at it. Now we're using this equation and this equation. Which one eliminates? 90T. This one cancels this. So what is 125L minus 90L? Positive 35L equals, what is 1485 minus 1170? 315. Do we know how to solve for L? Yes. Divide by 0.35. Divide by 0.35. We got L equals, how do we solve? 315 divided by 35. 9 times 5, that's 45. We got 4. 27 plus 4, that's 31. And that's 0. So 9 lilies. 9 lilies. So what do I write over here, Sabrina? L plus T equals 13. Instead of L, I'm going to substitute in the 9. Bring down the plus T equals 13. Minus 9 minus 9. T equals 4. So that's 2. Okay? I know. Now it's easy, right? And what is my last step? Check. So what would be my solution? The L comes first. So that what is the first number? 9. And the second one is 4. Once again, why did I write the 9 first? Because it belongs to L. And which is my first variable here? L. Okay? So let me write my first equation. L plus T equals 13. And over here the cost, 1.25 L plus 0.90 T equals 1485. All right, so therefore, let's see. We got 9 plus 4 equals 13. Is 13 equal 13? Yes. And over here, 9. And over here is 4. We got 1.25 plus 0.90 equals 1485. Let's see. 9 times this, what is that? I'll wait for you guys. Go. Okay, what is this right here, Gustavo?
11.25.
Plus, what else? Well, what is 90 times 4? 360. 1485. So this is 1485 equals to 1485. That is true. So therefore, my statement: Chaim will buy 9 lilies and 4 tulips. 10 cubes. Okay? So any questions with the item type of word problems? Okay, we got it, right? Okay, copy this down, example number 3. So this next one, notice these involve money and items. This next one does not involve that. So check this out. Example 3, copy that one down. Notice this one, it's a little different. It says, with a tailwind, an airplane makes a 900-mile trip in 2.25 hours. On the return trip, the plane flies against the wind and makes the trip in 3 hours. What is the speed, the plane speed, and what is the wind speed? Copy that, please. So notice on this kind of problem that it's there's no longer money or items. Here they're talking about, let's see, what is the question? What is the plane speed? They're talking about speed. That's a rate. What else are they talking about? 900 mile. What does that mean? Distance. And hours, that is time. So I'm pretty sure in science, your science teacher, they already gave you the formula, the DIRT formula. Have they addressed that? D equals RT, distance equals rate times time, right? So therefore, we're going to be using that formula for this. Here it goes. But before we do, let's read it, and then we're going to underline key information. With a tailwind, that's key information, tailwind, an airplane makes a 900-mile trip, 900 mile. And how long does it take? 2.25 hours. Okay. On the return trip, I'm going to change colors for the return trip. Return trip. The plane flies against the wind. I'm going to write against the wind. And makes the trip in 3 hours. 3 hours. And in green, what is the plane speed? They're talking about a plane. And what is the wind speed? So the second item or the second thing that they're talking about is wind. Okay, so plane and wind. So let me set up our table. Once again, 3 lines down. 1, 2, 3. And 2 lines across. Okay, and like I said, this is a rate problem, so I'm going to write here rate, the times, and then time, and that should equal distance. All right, so here we go. The first line is going to be for the first trip, which is in red, and I was going to label that tailwind. Tailwind. All right, tailwind. I'm pretty sure when you guys run your mile and it's windy, what happens when the wind is at your back? It's helping your rate, doesn't it? Makes you run faster. Well, here, for the rate, what are we talking about? They're talking about the plane and the wind. So I'm going to use those 2 variables. So for the rate of the plane, is that being helped with a tailwind?
Yes.
Yes, so that means plus W, because it's increased by the rate of the wind. How long did that trip take? 2.25. And what was the total distance? 900. Okay. So, against the wind. Against wind. So if it's against the wind, if it was with the wind, it increased. So what happens against the wind? So it decreased. So P minus W. How long was that trip? 3 hours. And what was the distance? What was the distance, everyone? 900, because it's the same distance on return. Now we already have variables and such. Let's write our equations. Our first one. I want to write P plus W. And what do I write to indicate multiplication? Very good. Parentheses. And then we got 2.25 equals 900. Let's write our second equation. P minus W times 3 equals 900. But it looks kind of funky, doesn't it? That means we need to get rid of those parentheses, right? So we can either distribute or, check this out, isn't the 3 multiplying? So how do we cancel it? Divide. So check this out. Look at this one. I'm going to divide by 3, divide by 3. What do I have left? P minus W equals 300. It wasn't the 3 multiplying? Okay. How about this one? Divide by 2.25. Divide by 2.25. We're left with P plus W equals, let's see, 900 divided by 2.25. Let's see, move it twice. 225 into here goes in there 4 times. 4, that's 900. 0. Does it fit again in 0? No. In the other one? No. So this is 400. By looking at it, what method can we use to solve? Elimination. Which ones eliminate? W's. And we're left with 2P equals 700 divided by 2 divided by 2. P equals 350. So let's see. What was the question? What's the plane speed? So what is the plane speed? 350 what? Miles per hour. So if that's the plane speed, which one of these can we use to solve for the, or these, can we solve for the other? It doesn't matter, right? I'm going to use the red one, so I'm going to use this one. P plus W equals 400, but instead of P is 350 plus W equals 400 minus 350 minus 350. We got W equals 50. So the wind speed is what? 50 miles per hour. Do we know how to check? Do we know our sentence? Yes. For homework tonight, it's on pages what? 359 to 360, numbers 1, 4, 7, and 8? And 8. Okay, guys, turn in your homework on your way out. The one from Thursday, we didn't turn it in on Friday. Turn it in. Have a good one, everyone. Enjoy your homework. See you guys tomorrow.